Welcome back to ACER Explained. In this series, I'm going through Section 3 of the practice test booklet from ACER. Well done if you've been following along for this long, because you're at the end, you're at the final unit. So going through questions 74 and 75 in this video, I'm going to be identifying prerequisite knowledge as usual, reasoning skills, and the bootcamp resources that you might need. In this unit, we're given some information on radioactive half-life as well as biological half-time. So starting with question 74, we're being asked about the radioactive half-life, and we are told that that is independent of the biological half-time. So half-time right now is irrelevant. We're just looking at half-life. So we're told that a material has a half-life of 10 minutes, and what that means is that every 10 minutes, 50% of that material is going to have, released its energy. So it's going to be 50% less than it was before. So we're being asked, how long would it take for this material to get rid of 90% of its material, right? To get rid of 90% of itself. So we start off with 100%, right? Over 10 minutes, we have our first half-life. Half-life number 1. So this is 10 minutes. Then another 10 minutes is our second half-life. So this is over 20 minutes. And we want to get to less than 10 because 100 minus 90 is equal to 10. So we want to get to around 10% left. Then we get to 12.5%, and that's another 10 minutes, so that's 30 minutes. And then we get down to around 6.25%, and so that's 40 minutes. So somewhere between here and here, we have 10% left. And so looking at our answer options, we have answer option B, which fits perfectly because between 30 and 40 minutes, you're going to be remaining with 10% of your original amount of that radioactive material. So the answer is B. So for this question, all the information that you needed was provided to you, and the reasoning skills that you needed to use were being able to just interpret that text and translating that to a little bit of maths as well. Now, there is a half-life formula that you could use as previous knowledge. However, it wasn't necessary in this question, and so that's why I didn't bring it up, because it would have honestly taken longer for you to figure out that equation and solve it that way than by just doing the method that was shown before. So the bootcamp resources that can help with this are the reasoning skills course and the acceleration class on calculations and formulae. So in this question, we're being asked about biological half-life. So a particular patient is injected with an isotope, and this isotope has a radioactive half-life of a few days, but that's irrelevant because we're told that it is independent of the biological half-time, and here in this question, we are concerned about the biological half-life. So 1% of this isotope remains between 13 and 24 hours later after this injection. And so what's the best estimate of the half-life? So what we're going to do first is start off with 100 as usual. Then we go down to 50, 25, 12.5, 6.25, 3.1 approximately, around 1.5, and then less than 1. So let's just say 0.7. Okay? So we have here 1, 2, 3, 4, 5, 6, 7 half-lives that have passed. So 1% of your isotope is going to be remaining somewhere in between here, in between 1.5 and 0.7. So we can say that this point is at 13 hours, and this point is at 24 hours, approximately, okay? And so this could be any more this way, and this could be any more this way. But we're being asked about the best estimate. So what I'm going to start off by doing is the process of elimination. So we could have 1, 2, 3, 4, 5, 6, 7 hours if 1 hour is each half-life. But we're told that this value of 1% lies between 13 and 24, which is inconsistent with this here, right? So we can eliminate option A. Then we have 2 hours. So we have 2, 4, 6, 8, 10, 12, 14. And so this is plausible. So we have 13 could be around here, and then 24 could be anywhere down here, right? And so that kind of makes sense because you have approximately 1% remaining from around 13 hours onwards. So this could be a viable option. Then we have 3. So I'm going to erase this once again. 3, 6, 9, 12, 15, 18, and 21. So up here, we have our 13 around here, and then we have our 24 down here somewhere. So this is a broader range, and so that's why this wouldn't be the best estimate, because that best estimate was the narrow range that we discussed earlier. So we can eliminate this one. Then we have 4 hours, which based on the 3-hour estimate, we can already assume is going to have an even broader range for us, which we don't want. But let's just kind of write that out anyways. So 4, 20, 24, 28, 32, and 36. So we basically have all the way from here, from 50% to 1%. Is the range from 13 to 24 hours. So that's an even broader range. So that's not the best estimate here. So the answer, therefore, would be B, because we're looking for the best estimate. Technically, 1% does remain between 13 and 24 hours if you're looking at these biological half-lives, but you're looking for the most accurate or the best estimate, and so for that, you'd look at B. So for this question, again, no previous knowledge was required. If you knew the half-life formula, you could have applied it here, but I want to keep the previous knowledge as little as possible just to show you that you can answer complicated GAMSAT questions without having that prerequisite knowledge. And so here it was just about interpreting the text once again and being able to translate it into that maths. And the bootcamp resources that can help with this are the same as I mentioned earlier. And that brings us to the end of Unit 24, and with that, the end of this practice test booklet. I hope that this was helpful. If you do have any questions, feel free to put them into the comments as well. Please like, share, and subscribe for more GAMSAT help. We really appreciate your feedback, and well done for getting this far. You made it, and hopefully you are able to make sense of some of those questions now. We have our Instagram at Thank Flip GAMSAT and our podcast, Thank Flip GAMSAT Nurses Doing GAMSAT, if you want to hear more from us. But other than that, I'll see you in the next one, and thank you for watching.